Hi, Derek from Distributed DBA here. As a database administrator, it's important to consider hardware failures when you're thinking about the availability of your data. This is a basic principle when setting up a high availability strategy. So today in this video, we're going to go over MySQL's default model to get a copy of your data to a secondary server using asynchronous replication. In MySQL, replication is the ability to transfer changes from one MySQL process to a secondary process. This is changes to your data caused by DML statements. Now, typically, the secondary MySQL process is listening on a second server so that you can achieve your high availability goals. But this is not always the case, and it's not a requirement. The default model of replication in MySQL is asynchronous. Asynchronous replication basically means that the user or an application that sends the DML changes to the primary doesn't wait around to make sure that those changes have made it to the secondary. And this is a very important concept when you consider the performance impact of setting up replication. Now, to configure replication in MySQL, the bare minimum that you need are two MySQL processes, obviously, with a copy of the data at the same point in time. Each of these processes must have a unique server ID as well. You also have to have connectivity between the two processes. Typically, that's networking. And it also includes setting up a user with the appropriate MySQL privileges to replicate changes from the primary to the secondary. And finally, you have to have binary logging enabled on your primary instance. So let's take a look at how we set that up. So here we are at my terminal where I have a primary instance on the left and a secondary instance on the right. Now, I did mention that one of the requirements for replication to work is to have a unique server ID on each server, and we have that configured appropriately. We also need to make sure that binary logging is enabled on the primary. This does not necessarily have to be enabled on the secondary, so we don't have that set up this way. Now, on our primary, we want to create the user that is going to replicate changes to anybody who connects with the correct credentials. So in this case, the correct privilege is replication slave to the REPL user. Now at this stage, since I started with an empty environment, each server should have no data, and indeed that is the case. So now on our primary, we're going to create a new database, and we're going to try to use this database on the primary. And if we try to do that on the secondary, we get an issue of unknown database. This is because the secondary server is not configured for replication. So let's go ahead and quickly create a new table called foo and insert some data into it. Now, we still don't have the database on the secondary, so let's go ahead and configure replication. To do that, we issue a change master command that tells the secondary where to reach the primary by connecting to the master host with the correct user credentials, and then we go ahead and execute that. We'll go ahead and start the slave, and then to make sure that everything is working, let's validate that replication is running correctly. To do that, there are three fields that you want to look at in show slave status. The first two are the slave IO and SQL threads are running. The IO thread receives the changes from the primary, while the SQL thread applies those changes on the secondary. And then we also take a look at seconds behind master to make sure that we're not lagging. It's not a perfect report of how many seconds behind the master the server is, but for our purposes, it gets us close. Now, if we come over here, we will see that I can then, on the secondary, use this database, and we can indeed select from our table that we created with some data. Great. Now, if I come over here to the primary instance, I want to insert another row, and on my secondary instance, we will look to see if that data got there. And indeed it did. One thing I like to point out is that the first insert before replication was working and the second insert after replication was configured and working returned in the exact same time. So there was no performance impact to my inserts, and this is why the replication is termed asynchronous. With MySQL's asynchronous replication, you get high availability with little to no performance impact. That's fantastic. Hang on though. Of course, there are some considerations that you need to be aware of about asynchronous replication, so you can plan for how that works in your environment. For one, if the change is replicated and is delayed to the secondary, you'll temporarily have data differences between your primary and secondary. If the data is actually different on your secondary, that replicated change may fail, and the primary won't care, leaving you to clean up the mess. And finally, if the primary instance dies before the change gets replicated to the secondary, you may end up with data loss. These are critical issues for you to understand and plan for in your environment. And if these can't be resolved for you to use asynchronous replication due to business requirements, then I do have some good news for you. MySQL does offer native semi-synchronous replication. In semi-synchronous replication, MySQL will wait until at least one secondary acknowledges receipt of the change before letting the client know that the change is accepted. So this gets rid of the issue with data loss at the expense of performance. It does not necessarily mean that if the data was different on the secondary that change won't fail. So you can still have that issue. So MySQL also has the ability to offer synchronous replication in newer versions using InnoDB group cluster. And there are third-party plugins like Galera that also offer synchronous replication. In this model, all changes are certified by all nodes in the topology before returning the write back to the client, accepting the write. So, of course, each of these models offer more guarantees of the changes of your data being received to multiple servers at the cost of performance. Basically, MySQL asynchronous replication gives you a quick win to setting up high availability strategy without cost to write performance. By understanding the implications of asynchronous replication, you'll be able to better understand and work with those issues, or be able to choose a stricter replication model at the cost of your write performance. Thanks for watching.